Hi everyone! So today we're going to be talking about factoring polynomials, and this is where we've been waiting to get to. So all that law of exponent stuff, all that knowing how to multiply polynomial stuff, it's finally come down to this. So first, before we start out, we probably want to do a little bit of vocabulary. We probably need to remember what a factor is, and a factor right now is going to express a polynomial as a product. It's not going to mean a whole lot now, it will later. We also have to remember the GCF, the greatest common factor, and this is going to be really important as we work throughout factoring. It's the common factor of a polynomial with the largest possible coefficient and the largest possible exponent. So we have to know that that's largest possible coefficient and the largest possible exponent or exponents. Could have more than one. We also need to know what a quadratic function is, because we're going to be dealing with a special type of polynomial a little bit later on, quadratics. And a quadratic function is a second degree polynomial. So all that this means, second degree, is that our exponent is going to have a square. And if we look at our standard form of a quadratic right now, we can see that that's going to be where we have ax squared plus bx plus c. And our exponent here, our largest exponent, is going to be that second degree, a number 2. And our factored form of a quadratic is x plus p times x plus q equal to 0 when we start solving. The first thing that we're going to factor is going to be factoring with GCF. So before we even start that, we probably want to be able to identify the GCF. So if we look at two terms, 2x squared and 30x to the 5th. Again, our GCF is our greatest common factor of a polynomial that has the largest coefficient and the largest exponent. So looking at just the numbers, what's the biggest number that will go into 20 and 30? Hopefully when we look at this, we can see that it's 10. 10 will go into 20 and 10 will go into 30. And so next we have to look at the exponents. What's the largest exponent that will go into both 2 and 5? And hopefully we see that it's going to be 2. Okay, when we take that out, we're left with the other remaining factors, which is what we're going to see in example 2. So our directions here in example 2 are actually to factor this. So the first thing we always want to do is look to see if there's a GCF. Is there a number that 7 and 14 have in common? Hopefully we realize that it's going to be 7. There is no exponent here, so I'm going to just be left with, if I divide each of these by 7, that's ultimately what we're doing when we factor. We're undoing that multiplication. We're going to divide by 7, so we're left with x squared plus 2. Now if we go back to multiplying, the way we can check this is if we took the time to multiply or distribute the 7, we would get 7x squared plus 14, which is actually what we started with. If that works, then it's checked out and we're correct. Okay, so on number 3, again, we're looking for that GCF. So what do 16 and 20, what's the largest number that will go into both of those? 4. What's the largest exponent that will go into x cubed and x squared? X squared. And so again, we're ultimately dividing by 4x squared. So if I divide 16x to the 3rd divided by 4x to the 2nd, I'm left with 4x plus, and if I divide 20x squared divided by 4x to the 2nd, I'm left with 5. And again, this goes back to our laws of exponents. How do we divide these? Okay. Let's look at the next one, example 4. So we have 15x squared minus 12x to the 4th plus 27x cubed minus 3x squared. So this is a really long factorization problem here. But again, let's just look at our coefficients. What number do 15, 12, 27, and 3 have in common? 3. And now let's look at our exponents. What do x to the 5th, x to the 4th, x to the 3rd, and x to the 2nd have in common? X to the 2nd. So again, this becomes like a little division problem. What happens if I divide 3x squared by every single term here? What am I going to be left with? And again, we saw this with laws of exponents just earlier. So if we look at this, 15 divided by 3, we know we're going to be left with 5. X to the 5th divided by x to the 2nd, our law of exponents tells us we're going to subtract those, so we'll get x cubed minus 12 divided by 3 is 4. X to the 4th divided by x cubed, x squared is going to be 2 x to the second plus 27 divided by 3 is 9. X cubed divided x cubed is gone. And then 3 divided by 3 is 1. And on this one, we're actually going to have like a weird remainder. We know that we have an exponent in the bottom, so it's actually going to be 1 over x. Kind of a weird answer. And I wrote it a weird way. Sorry about that. But that's what we would call a remainder. All right, and now let's look at our last example. This one's really tricky. Unlike all the other examples that we've seen where we can just factor out a number, if we look really closely, our factor should be kind of obvious. What do our first term and our second term have in common? Can we tell? Hopefully we can see that they both have this x plus 1, which means if I factor that out like everything else, whoops, that's supposed to be a 1. I'm going to factor that out. So I'm dividing this whole thing by x plus 1 and this whole thing by x plus 1. So what's going to happen, since it's in my numerator and denominator, it's going to cancel out, and I'm just going to be left with x squared. And over here, since it's in my numerator and denominator, I'm going to cancel it out and just be left with 2. So whenever we have like a whole binomial factor, we kind of just rewrite it. So x plus 1 times x squared plus 2. I know that one was a little confusing. Let's try and see a couple of on our own. So here we go. Why don't you guys try examples 1 through 4? I'm going to give you guys a moment to pause the video. Now that we're done solving, hopefully we got these answers. Check to see if you're correct. Next, we're going to learn to factor by grouping. So this is going to be a little bit different, but we're going to start off the same way. First thing we want to do is look to see if we have a GCF between all of our terms. Since we don't have a number in common between any of our terms, we're going to go ahead and start our grouping. So with our grouping, we like to group 2 things at a time. So I'm going to group 6x cubed together, and I'm going to group 4x plus 6 together. I should have incorporated that positive. Okay, so now we're going to check to see if we have a GCF. Is there something in common between 6x cubed and 9x squared? Do we know that it's going to be a 3x to the second? Hopefully we know that that's what they have in common. Once we divide each of those by 3x to the second, we're going to get 2x minus 3. Okay, next thing we want to do is look what's common between 4x and negative 6. The only thing that 4x and 6 have in common is going to be a 2, a positive 2. And when we divide each of those by 2, we're left with 2x minus 3. Okay, does this look kind of familiar to us? It should. This is the last thing that we saw with factoring with our GCF. Once we do that, we should notice that we have a 2x minus 3 in common between both of those terms. So what I'm going to do is factor those out. What does that mean? Well, that means I'm going to divide both of these by 2x minus 3. So if I do that, I'm going to be left with our 3x squared plus 2 when I cancel out what they have in common. So our factored answer is going to be 2x minus 3 times 3x squared plus 2. That might have been a little confusing. Let's look at another example. Okay, so on example 2, if we look at this one, we have 2x cubed minus 6x squared minus x plus 3. When we look at this, we know that there's no GCF between all 4 terms, so we're just going to group these in groups of 2. So here's my first group, here's my second group. This time I actually caught the sign in there. Okay, first thing I want to do, what do 2x cubed and negative 6x squared have in common? Hopefully we're able to identify that they each have a 2x squared in common. So when I divide each of these by 2x squared, I'm going to be left with x minus 3. If I look over here, I notice that x and 3 don't have any same coefficients, anything like that. But I also see that I have a negative x right here. Because we're working with our quadratics, one of the things we have to notice when we're looking in standard form and factored form is that we rarely have a negative x. So I don't want to have one right now. So when I look at this closely, I actually do have something in common between negative x and 3. It's going to be a negative 1. And if I divide each of these by a negative 1, what's going to happen here is my negatives are going to cancel out. X divided by 1 is x. 3 divided by negative 1 will be negative 3. Now we had to do that so that we can see what the GCF is at this point. Hopefully we're able to tell that it's going to be x minus 3. And again, we're really going to just divide each side by x minus 3. So, whoops, minus, that's a minus sign in there. So when we do that, we're going to cancel out our x minus 3's, because that's what we factored out. And what we're left with is 2x squared minus 1. And now we're done, and we have our factored form. Again, I know this is probably a little confusing, so we're going to try one more together. Might be a little bit harder. Okay, so the first thing that we want to do here on example 3 is check to see if we have a GCF. So do 12, 20, 21, and 35 have something in common? Do x to the 5th, 20x squared, or sorry, x squared, x to the 3rd, and 35 have something in common? There's no common exponent and there's no common coefficient. So we're going to go ahead and group these. So my first group and my second group. In my first group, what do 12x to the 5th and 20x squared have in common? Hopefully we can tell that they both have a 12. No, they don't. That they both have a 4x squared in common. And when we divide both sides by 4x squared, not both sides, both terms by 4x squared, we're going to be left with 3x cubed plus 5. Okay. If we look at our next two terms, what do negative 21x cubed and negative 35 have in common? Well, the only thing these two have in common is just a negative 7. So I'm going to go ahead and factor that out. And when I do factor out that negative 7, I'm left with 3x cubed plus 5. At this point, we should probably realize that we have a GCF here. But, oops, I did forget to put the negative 7 there. Whoops, there we go. There it is. Okay, so now we can factor out that 3x cubed plus 5. And we're left with 4x squared minus 7. Okay. Hopefully this hasn't been too confusing. Why don't you guys try some on your own? Try 1 and 2, take a moment now, and pause the video. Are these the answers that you got? If you did, then you're correct. Great job. All right, so now we've gotten to the hardest part of factoring. Maybe not the hardest part, maybe the second toughest part. So here it is. However, we're kind of already prepared for how to solve this. What we're going to do right now is something called an X puzzle. Now, the first thing I want to remember is that my coefficient that I don't see in front of that X is 1. This is really important. So if we remember, let me go back, that when we started talking about our quadratics, we said that standard form of a quadratic was ax squared plus bx plus c. Note that a is our coefficient in front of our x squared, and b is our coefficient in front of the x, and c is our constant, just that number that's hanging out. So the first thing I'm going to do is multiply my a times my c. Okay? And what's 12 times 1? Well, that's 12. Now I'm going to make something called an X puzzle. It's an X puzzle because we can see it's an actual X here. And in the top part of my X puzzle is just my answer to me multiplying A times C. The bottom part of my X puzzle is going to be whatever we have as our coefficient in front of B. So this might be a little confusing right now. Take time to think that over. The next part for solving or for factoring trinomials at this point is to think, what will give me, what will multiply to 12, so I'm going to put a little multiplication symbol here, that will add up to 7. So take some time right now to think of two numbers that multiply to give us 12 and add to give us 7. This is really going to take some multiplication knowledge here. Hopefully the two numbers we came up with were 3 and 4. So I'm just going to put those here on the side because 3 times 4 gives us 12 and 3 plus 4 gives us 7. Okay? So now that we've done the X puzzle, the very next thing we're going to do is something that you guys should be familiar with. It's that box. Remember when we had that box before? Yeah. Well, this time we were multiplying what was on the outside to get our box inside. Now, and this will only work with trinomials, what we're going to do is put things that we know inside. So I'm going to put the x squared here in the top. It always goes in the top left corner. I'm going to put that 12, that constant, in the bottom right. That always goes in the bottom right corner. And now, to fill in these two boxes, I'm going to fill those in with the numbers that I have on the sides. I promise this seems really confusing, but after a while it gets super easy. And I'm just going to put an X there because those are eventually going to be my terms. So now what I have to do is think. What do x squared and 3x have in common? What's their GCF? Hopefully the only thing we realize they have in common is an x, so I'm just going to write it above. Now I'm going to look at what 4x and 12 have in common. And 4x and 12 only have 4 in common, so I'm going to write that above. Okay. Next, I'm going to go horizontally. What do x squared and 4x have in common? Well, the only thing those two have in common is x. And what do 3x and 12 have in common? Well, the only thing those two have in common is 3. And that's it. I'm done. Now, all I have to do is write my answer in factored form. So what is my answer? Well, your answer is going to be whatever you have on top. We kind of just want to think about our parentheses around this. Remember, factored form is always x plus p times x plus q. So in our case, it's going to be x plus 4, because this is a positive 4, times x plus 3. And this is going to be our final factored answer. I know, kind of tricky. Don't worry, we're going to try another one. So let's look at example 2. First thing we want to do is set up our X puzzle. So let's go ahead and do that. And remember, to get that top number, we have to multiply 12 times that coefficient, which is 1. And that's going to be 12. And then this bottom number is just going to be that b coefficient, so -8. So now we have to think, what times what gives me 12, but adds up to a -8? Because we have a negative here, most of us have to realize that there's going to be a negative somewhere. So let's think of the factors of 12 that will give me some kind of 8. Hopefully we're okay to see, and again, this is where multiplying comes in, that it's going to be a -6 times a -2. -6 times a -2 does give me a positive 12. Negative times a negative is a positive, but a -6 plus a -2 is 8. So now that I've done my X puzzle, I'm going to go ahead and do my box. I'm going to set up the numbers that I definitely know. My y squared and my 12. And now I'm going to plug in my -6y and my -2y. Just those two numbers. And it doesn't matter where I put them in. Okay, so the first thing I want to do is find the GCF between between x squared and -6y. Sorry, that's a y squared and -6y. Hopefully we come up with y. And now what's my GCF between -2 and 12? Hopefully we realize that it's going to be a -2. Remember, we always like to pull out that negative. Okay. Then we're going to figure out our GCF between y squared and -2y, and that's going to be y. And then -6y and 12, and that's going to be a -6. What we notice is if we go ahead and multiply those back out like we did when we were multiplying our polynomials, y times y is y squared, -2 times y is -2y, y times -6 is -6y, and -6 times -2 is a positive 12. So now that we have that, we have our factors. This time we actually see that we have a negative here. So our factor here is going to be y minus 2, because it's a negative, times y minus 6. So that's why it's so important to know what those signs are. All right, so hopefully we're getting used to the format of solving this. We need an X puzzle in a box. I went ahead and multiplied my negative 20 times 1. That gives me negative 20. And we took our B coefficient and put it right here at the bottom of our X puzzle. So now I have to decide what times what will give me a negative 20. Again, we want to come up with a negative 20. This is really important. That will add up to give us a negative 8. Take some time to think about it. But the answers that we should come up with are a negative 10 and a positive 2. Negative 10 times 2 is negative 20. Negative 10 plus 2 is negative 8. So I'm going to go ahead and plug in what I definitely know. I know x squared, and I know negative 20. So now I'm going to fill in my negative 10x and my positive 2x. Now I'm going to go ahead and find my GCFs for each column and row. So my first column, what do x squared and negative 10x have in common? X. What do 2x and negative 20 have in common? 2. What do x squared and 2x have in common? X. And the GCF between negative 10x and negative 20 is negative 10. So now we have that. We can see what our factors are going to be. X plus 2, because we know it's a positive 2, and x minus 10. And again, if we wanted to check really quick, we could check our multiplication there to make sure everything is correct. There's the factors. All right, hopefully this is getting a little bit easier, maybe to the point of boring. We just have a couple more examples. I lied, a few, 3. So let's try the next one. Again, I'm going to see my trinomial. I'm going to start off with an X puzzle and a box. And you know what? I already know my n squared is going to go in this box. But if I notice, there's something really interesting about this example 4. Why is it different than example 1, 2, and 3? Oh, is it because this is not written in descending order? So the first thing I need to do is actually write it in descending order. So let's do that now. Remember, descending order has our exponent, our largest exponent first. Eek. I didn't want to get in the way of the X puzzle. So we actually have n squared plus 5n minus 24. So now I can go ahead and finish my box with my negative 24 here. All right, so now I'm going to go ahead and multiply. Whoops, I guess I should put it right here. And multiply negative 24 times 1 is going to be negative 24. And then my bottom is my B coefficient, 5. So now I need to think of two numbers that multiply to give me a negative 24, but a positive 5. And let's think about that. We know it's going to be a positive 8 and a negative 3. Again, positive 8 times negative 3 gives us a negative 24, but when we add them together, 8 minus 3 or 8 plus negative 3 gives us a positive 5x. So I'm going to go ahead and put those in to my box. And now it's time to factor out some GCFs. So the first thing we want to do, what do n squared and 8n have in common? And what do negative 3n and negative 24 have in common? Negative 3. What do n squared and negative 3n have in common? N. And what do 8 and negative 24 have in common? 8. So now that we found the GCFs for all of those, we have our final factored form. N minus 3 times n plus 8. All right. We only have 2 more to go. So the next one's a little bit tricky. One of the things I haven't been saying, aside from when we're in the box, is that word GCF. But we actually need it right now. And this is something that I should have done the whole time. Every time we look at a trinomial, we should look to see if they have anything in common that we can factor out first. So let's try that now. What do 2x cubed, negative 20x squared, and 50x have in common? Hopefully we can tell that their GCF, which we haven't seen in a long time, but we're going to factor out now, is going to be 2x. And when we factor that out, we end up with x squared minus 10x plus 25. So this is very similar to factoring out using our GCF. So now that we have that, we can go ahead and have our x puzzle. I'm going to put like a big arrow right here and right here because that 2x is going to be important to us a little bit later on. We just don't know that now. So now that we have that, I'm going to make my x puzzle and my box. Needed a smaller box here. Running out of room. Okay. And again, now that I have everything, I'm going to just go ahead and put what I know in my box. Now what I'm going to do is multiply 25 times 1. We know is going to be 25 and negative 10. So what times what gives us a positive 25 but a negative 10? Hopefully we know that it's going to be a negative 5 and a negative 5. So I'm going to go ahead and put those in. Negative 5x and negative 5x. So if we look, now it's time to get that GCF. What do x squared and negative 5x have in common? X. What do negative 5x and 25 have in common? Negative 5. What do x squared and negative 5x have in common? X. And the GCF for negative 5x and 25 is negative 5 again. So if we look at this, we now have our factors. So we know it's going to be x minus 5 and x minus 5. So there's a couple of things that we're going to do here. I'm going to go ahead and put my x minus 5 and my x minus 5. But remember, we had that 2x. So we also need to incorporate that. So I'm going to bring that over here and put it in front of my factors. But what we notice also is that this factor is the same as that factor. So there actually is a simpler way that we can write this out also. We can have, instead of 2x times x minus 5 times x minus 5, we can also have, I guess I should put a big or here, or we can have 2x times x minus 5 to the second power, because we know that from our laws of exponents that it means what we're multiplying twice. And since we're multiplying that twice, we can get that for an answer. All right, so let's look at our last example with these factoring trinomials. If we look at this, one of the things that I haven't been doing is looking at our GCF. So do we have a GCF between negative x squared, 3x, and 18? We probably don't remember, but we need to know that that's actually that invisible 1. So what I'm going to do is factor out that invisible negative 1. And what I'm going to be left with is x squared minus 3x minus 18. So this is just like when we just factored out GCFs. We don't want to have that leading coefficient being negative. So again, I'm going to put my really obnoxiously large arrows here. Okay, that one wasn't super obnoxiously large because I want to remember that that negative 1 is there. And now I can go ahead and move on to my x puzzle and box. So x puzzle and box. And again, I'm going to fill in everything that I know so far. So x squared and negative 18. So now I can go on and move along. So negative 18 times 1 is going to be negative 18. And then we have our b coefficient. So what times what gives me a negative 18 and a negative 3? When we think about those factors, hopefully we come up with negative 6 and a positive 3. And let's see if that checks out. Negative 6 times positive 3 does equal negative 18. And negative 6 times positive 3 does equal, when we add up, sorry, I didn't mean times. When we add up negative 6 plus 3, we do get a negative 3. So now I'm going to go ahead and put those in my box. Now it's time to GCF everything up. So x squared and negative 6x has an x in common. 3x and negative 18 has a 3 in common. GCFs horizontally. X squared and 3x has an x in common. And negative 6x and negative 18 has a negative 6 in common. So we have our factors. But remember, we also have that negative 1. So I'm going to put that guy first. So we have our factors of negative 1 times x plus 3 and x minus 6. And now we're done. I'm hoping that we really enjoyed factoring trinomials with x squared plus bx plus c, because now we have the added coefficient of an a. So what we notice about our first couple of examples is that instead of it just being a 1, that invisible 1, we have an actual coefficient number in front of our x squared. So we're going to start off the same way. First, our GCF, which I haven't been doing. Is there anything common between 6, 11, and 4? No. So I'm just going to go ahead, because it's a trinomial, and anytime I know I'm factoring trinomials, I know it's going to have an x puzzle and a box. So since everything's written correctly, I'm just going to go ahead and fill in everything I already know. So now I'm going to multiply. 6 times 4 we know is going to be 24, a positive, and then negative 11, our b, goes in our bottom part. So what times what gives me a positive 24 but a negative 11? Hopefully we come up with negative 8 and negative 3. Negative 8 times negative 3, positive 24, negative 8 plus negative 3, negative 11. So I'm just going to throw those guys into our box. And if we look here, we have 6x squared and 8x. What do those two have in common? So this is going to be a little bit different for our GCF. Usually it was just an x. Now 6 and negative 8 actually have a 2x in common. Negative 3x and 4, what do they have in common? Nothing really, aside from good old negative 1. Remember, that's always a factor. 1 is always a factor. Okay, now let's find our GCF. 6x squared and negative 3x have 3x in common, and negative 8x and 4 have a negative 1 in common, and negative 8x and 4 have a negative 4 in common. Sorry about that. So now we can go ahead and not multiply. I guess we could multiply to check. 2x and 3x have a 6x squared. Negative 1 and 3x have a negative 3x. Negative 4 and 2x have negative 8x. And negative 4 and negative 1 have a positive 4. So now we can go ahead and write our factors. And our factors are going to be 3x minus 4 times 2x minus 1. All right. Let's look at, and this is our answer. Boop. Okay, so all right, now let's look at our next one, number 2. So first thing we want to do is check to see if we have a GCF. 24x squared minus 76x plus 40. Uh-oh, guess what? We do have a GCF here. Do we know what it is? This one's a little tricky. We have to have our multiplication game going on right now. Our GCF is actually going to be a positive 4. So once we get that factored out, we'll have 6x squared minus 19x plus 10 as our trinomial that we want to factor now. Again, I want to put my arrow here. I'll only put one obnoxious arrow there. I'm going to need that room for later. Now that we have that, we can go ahead and set up our X puzzle and box. And because everything's written in correct form, I'm going to go ahead and substitute in my box everything that I already know. Now we can go ahead and work with our exponent. Positive 10 times 6 is 60, and our negative 19 goes in our bottom part of our X puzzle. Now we have to think, what times what is 60? That will add up to give me a negative 19. We already know that the answers are going to be negative because a negative times a negative is a positive, and a negative plus a negative is a negative. So this time it's going to be 4 and 15. So I'm going to go ahead and put those in my box. Now we can go ahead and start finding GCFs. So GCF between negative 6x squared and negative 4x is going to be negative 2x. No, it's not. It's going to be positive 2x. Then our GCF between negative 15x and 10 is going to be a negative 5. Let me get my red marker. Our GCF between 6x squared and negative 15x is going to be 3x. And our GCF between negative 4x and positive 10 is going to be a negative 2. Again, if we want to go ahead and check our multiplication, it's not a negative 2. Oh my goodness. 2x times 3x does give us 6x squared. 3x times negative 5 gives us negative 15x. 2x times negative 2 gives us negative 4x. And negative 2 times negative 5 is 10. Whew. All right. So now that we have that, we now know our factors. I'm going to go ahead and drop this 4 down because I know that it's just going to be hanging out with the rest of our factors. And I'm going to list all of my other factors. 2x minus 5 times 3x minus 2. And now we have complete factored form. All right, let's look at our next example. We have 10x squared plus 37x plus 7. Just for fun, let's look to see if I have a GCF between any of my terms. I don't. So since I don't, I can go ahead and just set up my X puzzle and my box. While we're doing this, we know that the great thing about X puzzle and box or trinomials is that it's going to be the same thing, however boring, always. So when we look at this, now I can go ahead, multiply my 7 times 10. We know that that's going to be 70. And my B is going to be that bottom part of my X puzzle. What's great is that these two are actually positives. But what's not so great is we have to find a lot of factors of 70 to get to add up to 37. I'll make it quick. I'll make it 35 and 2. So now that we have those, we're just going to go ahead, put those in our box. And now we can go ahead and find some GCFs. So the GCF between 10x squared and 35 is going to be 5x. The GCF between 2x and 7 is going to be 1. Remember, when they don't have anything in common, they always at least have a 1 in common. The GCF between 10x squared and 2x is going to be 2x. And the GCF between 35x and 7 is going to be 7. If we want to go ahead and take a quick look at our multiplying, we know we've got everything correct there. Now I can just go ahead and write my factors. So 5x plus 1 times 2x plus 7. And there we go. All right. 2 more examples. Let's get to it. Number 4. Hey, anything interesting you notice here? That's not written in descending order. So let's go ahead and start this off by actually writing it in descending order. So I'm going to have negative 3x squared plus 10x plus 8. Anything interesting you see here now? Oh, we have a negative coefficient here, and we don't want that, so we need to factor that out. So aside from that negative, is there anything else they have in common? No. So let's just factor out our negative 1. And we're going to be left with 3x squared whoops, I forgot the x right there, minus 10x minus 8. I'm going to put my semi-large arrow there so I can remember to bring that down. And now I can go ahead and just continue factoring like we've been doing for the last, billion problems. I'm going to put my X puzzle. I'm going to put my box. Since everything is now correct with my trinomial, I can fill in the pieces of my box that I already know. And now we're going to go ahead and multiply. Negative 8 times positive 3 is going to be negative 24. And our coefficient of that b is going to be negative 10. So now we have to think what times what gives us a negative 24 and a negative 10. So on this one, we at least know one of our numbers is going to be negative, the larger one, and then one's going to be positive. And so this is actually going to be a negative 12 and a positive 2. Multiply to negative 24, add up to negative 10. I'm going to go ahead and put those in my box. And now we can get some GCF action happening. So 3x squared and negative 12x have a 3x in common. 2x and negative 8 have a 2 in common. Okay, no idea what happened with the camera right there, but it stopped. I think everything's good. So have no idea where I left off there, but let's just say we got all of our factors here from our box, and now we're going to go ahead and put everything where it belongs. Again, we already factored out our negative 1, so we need to have that brought down, and then we found our two factors, 3x plus 2 and x minus 4. So now that we have that, we have our complete factored form. All right, so here's the exciting part. Last practice problem. Okay, or last example problem. You guys will have some practice. So what we first have to do is check to see if we have anything in common between 6p, negative p squared, negative 13pq, and negative 28q squared. Don't let it bother you that we have two variables here. We're going to solve this the exact same way. Kind of forget that those even exist. So if it's going to be the exact same way, we know we're going to need our X puzzle and our box. Since I have some room on this paper, I'm gladly taking it. Everything's written in order, so I'm just going to put in what I already know. Okay, so now that we've done that, we're going to go ahead and multiply a times c. 6 times negative 28 is going to be negative 168, and we'll just put our negative 13 right here. All right, I know this is a super large number, and most of the time we won't really have real quick ideas what's going to multiply to that. It took me a while also, so don't fret. But do remember, you need to know your multiplication. I'm going to help you on this one. It's going to be a positive 8 and a negative 21. Positive 8, negative 21 will give us negative 168, and they'll add up to give us a negative 13. So I'm going to put these in my box. These are going to look a little different because this is actually going to have whatever's in that middle term variable. So it's going to be 8pq. And then negative 21 PQ. No idea why my finger slipped over there. All right, so now we're going to go ahead get some GCF happening. So 6p squared and 8pq have a 2p in common. Oh, don't know why I capped up my marker. Negative 21 PQ and negative 28Q squared have a negative 7, wait for it, Q. So that's where that Q is coming in. So don't worry about it. It got all taken care of with the GCF. 6P squared times negative 21PQ has a 3P in common. And our GCF between 8PQ and negative 28Q squared is going to be a 4Q. Okay, so now that we have that, if we want to go ahead and check our multiplying, again, when we multiply those back, we get that PQ that we need to have. We've had nothing factored out, so I can just go ahead and write my factors here. 2P minus 7Q times 3P plus 4Q. And we're done. And we're done with factoring trinomials in the terms ax squared plus bx plus c. You're going to be super happy. This is our last type of factoring. I know this was a really long video, but we're done after factoring difference of squares. So we first have to know what difference of squares means. So difference of squares is a squared minus b squared. It's going to be two squares only two terms. And what's nice about this is it's always going to be in this form, a plus b times a minus b. Looks a little tricky right now. We're going to see it in action with example 1. So I know that this is a perfect square, x squared, because it has the 2. I know that this is a perfect square. That's the one thing we care about, if they're perfect squares. Since they're perfect squares, excuse me, we know we're going to have x plus 2 times x minus 2. If we look at example 2, first thing we want to look at is this a perfect square? Yes, because it's 2. Is this a perfect square? Yes, because 2 times 2 equals 4, and we have a square here. So again, we're going to follow this order of m plus 2p times m minus 2p. That's it. Let's look at example 3. Uh-oh, you know what I've been forgetting to do? That's right, looking for a GCF. So here's where we're going to look for it. Do I have something in common between 18x squared and 50x to the 6th power? Yes, I do. Hopefully, we can tell that we have a 2x squared as their GCF. I always forget to do that, so make sure you check that whenever you're working with polynomials. So that's going to leave us with 9 minus 25x to the 4th. Okay, so now we have to ask ourselves, is this a perfect square? Yes. Is this a perfect square? Yes. So now we can go ahead and factor like we've been factoring. So we're going to keep 9, which is 3 times 3, plus 25, x to the 4th, which is 5x squared, times 3 minus 5x squared. But I know what you're thinking. You forgot your 2x squared because you didn't have your big arrow. Well, I didn't forget it, but I'll put the big arrow after the fact anyway. So this is actually going to be our answer, this whole thing here. Obviously, you can tell I had some issues with example 4 during a previous filming, so we're going to move on from that right now. So please disregard my yellow sticky there. Let's look at example 4. 49x to the 4th minus 9x to the 6th. First thing we want to do is always check to see if we have a GCF. In this case, we do. X to the 4th. So I'm going to take that out and be left with 49 minus 9x to the 2nd. Now that we've taken out our GCF or factored out our GCF, I can go ahead and follow my difference of squares rules. So we know it's going to be 7 plus 3x and 7 minus 3x. I did not leave myself enough room because I now have to go in and put my x to the 4th right here. We'll just cover up that equal sign. Lots of mistakes on example 4. Sorry, guys. All right, so now you try some on your own. Take a moment to pause the video. Hopefully you got all of these correct. If not, try them again.